Okay, good afternoon, everyone. Right. So today, we will discuss for exercise 4.3 and also exercise paper 1. Okay. So for your information, for the next 2 weeks, okay, we will not have a class because it's school holiday. Okay. So starting on the next Sunday and another Sunday, we will not have a class. Okay. So all right. So exercise 4.3. Okay. So before we discuss about exercise 4.3, so 4.3 is actually about specific latent heat. Okay. So specific latent heat. So this is the heating curve. Okay. So we do some review. Okay. Some revision. Okay. About specific latent heat. Okay. So this is the heating curve, right? So here, okay. So what does it mean by specific latent heat? Okay, so specific latent heat. So anyone you want to try? What does it mean by specific latent heat? Can you still remember what's the meaning by specific latent heat? Specific latent heat. Before this, last week we learned about specific heat capacity, right? So specific latent heat, amount of heat energy required to change the state of 1 kilogram of substance. Okay, so you miss one keywords there. There is a without change in temperature. Okay, or constant temperature. Okay, so the energy need, right? Or energy required to change a phase, okay, for 1 kg of substance, okay, without change in temperature or in a constant temperature also can. Alright, so that is the meaning of a specific latent heat. So it's different from the specific heat capacity where the energy is used to increase the temperature. But for the specific latent heat, the energy will not used to increase the temperature, but it's only used to break a bond or to form a bond. Okay, so let's see for this one. So this one, you mean you can see here the temperature is increased. So this one is a specific heat capacity. Alright, and you know the formula used is Q is equals to MC theta. Alright, and then for this one, okay, so you can see there is a change of phase here. So when melting means it's changed from solid to liquid. So this one is the specific heat, specific latent heat. So there are two types of specific latent heat, right? So the first one is the fusion, okay, specific latent heat of fusion, and another one is the specific latent heat of vaporization. So fusion is from solid to liquid or liquid to solid. Right? So for vaporization is liquid to gas, right? Or gas to liquid. Okay, for this one, this is specific latent heat of fusion. Okay, so you can see there is no change in temperature here. So the temperature is not changed. All right. So if the question asks, okay, what does the energy? Okay, why does the temperature does not increase? Okay, when the solid or when the ice is melting. Okay, so your answer should be what? The energy is used to what? Why there is no change in temperature even you keep giving the heat energy to the substance will not increase the temperature. What happened? Yeah, because the heat is required to break the bond. Okay, but for here at this part, okay, so the energy here is used to increase the kinetic energy. For the specific heat capacity, if they ask why the temperature keep increase, because this one the energy is used to increase the kinetic energy. Okay, why does the temperature is increased here? Because the heat is used to increase the kinetic energy. This one the energy is used to break the bond. Okay, all right, and then here if you want to calculate, right, if you want to calculate the heat energy, okay, for the specific latent heat, so this one we use Q is equals to ml, right? Q is equals to ml. So M is the mass here, L is the value of the specific latent heat. Okay. All right. And then for this one, okay, this one is again Q is equals to MC theta. This is the specific heat capacity. And this one boiling means, okay, at C and D. So this is the boiling, right? So boiling process will mean here the liquid will change to gas. So there is a phase change and there is no increase in temperature. So for this one, we call it as the specific latent heat of vaporization. Okay. And again, if you want to use the formula to calculate the energy, so we use Q is equals to ml. Okay, so that is the basically what you have to know for the specific latent heat. Okay, you have to know the meaning. Okay, what type of specific latent heat, what happened during the specific latent heat, what happened to the energy, okay, and how to calculate. Okay, so let's see the first question. Oops. Okay, for number 25, right? It says here, diagram 30 shows a melting curve for a solid with a mass 600 gram and heated by electrical heater of 2 kilowatt. So what time will be used to calculate the specific latent heat of fusion? So this one we already discussed, right? So what you think the answer is? Which one is the fusion part? B. Okay, correct. So B and C. Okay, so this one AB is a solid. Alright, BC is a solid change to liquid. Remember just now I said specific latent heat of fusion means solid change to liquid or liquid change to solid, also we call it as the specific latent heat of fusion. Okay, so means here it said which one to calculate the specific latent heat of fusion. So at B and C. So at D and E, this one is the specific latent heat of vaporization. Okay, so the next question. Okay, at which stage the substance in the liquid and gases state at the same time? So what's your answer? Yeah, the answer is D, S and T. Okay, this is solid, solid plus liquid, liquid, this one is liquid, this is liquid and gas, then after that it will totally become gas. Alright, for number 19, okay, in the laboratory, water boils at 100 degrees Celsius. What happened to the boiling point, okay, when sugar is added to a water? So what you think happened to the boiling point here? Yeah, it should be increased, okay? Should be increased. Just like when you answer the question, right, for the, you have to remember last week we discussed about the box, the ice box. Remember you have to make it cool faster. All right. So that one you add salt, right, to reduce the to decrease the freezing point. So this one to increase the boiling point. Oh, already discussed about 4.3, is it? Until what question? Oh, really? Until here? Is it? Oh, for M haven't. Oh, I think only objective, right? For M haven't. I think until objective. Last week we just discussed a few questions. Is it okay if I just discuss it again? Yeah, I think can, right? Okay, so is that me I just go through. Okay, so number 20. So which of the following process, okay, involve the absorption of the latent heat? So heat absorbed means this one is the melting and boiling. Okay, melting and boiling. For let's say condensation, condensation is from gas to liquid. So that one is the release of heat. So the heat will be released to form a bond. Okay, to form a bond. Okay, number 21. So it says here more heat energy required to change 1 kilogram of 100 degrees Celsius to steam, okay, of water to steam, then totally melt 1 kg of ice, okay. So this one because we already discussed in our class, right? So because if you change the liquid to gas, right, the gas need to overcome, okay, it need to overcome two condition. The first one, okay, the has to break the bond, and the second one is come from the atmospheric pressure, because it has to be released to the atmospheric pressure once it's already changed to gas. Okay, so there are two conditions that is need to overcome when you want to change to gas. The first one is from they need to break the bond, okay, between the molecule, and the second one from the atmosphere, from the gas. But if let's say solid to liquid, they only need to break the bond between the molecules. So that's why they need more energy. Okay, so this one is actually the answer is specific latent of heat vaporization is okay higher. So the answer is C. Okay, number 28. Okay, so number 28, which of the following statement is not correct? So here it said the energy being absorbed in BC is heat of fusion. Yes, correct. So this one is liquid and solid and liquid. And the energy being absorbed in D and E is vaporization. Yes, correct. R is the boiling point. Okay, R is the boiling point. No, right? So the boiling point, okay, so the boiling point is actually at Q, not R. Okay, so this one, the answer is C. Okay, for this part, okay, so here it says what is the function of setting up a control experiment? Okay, so you know, okay, this is actually to find the specific latent heat of water, okay, of ice, sorry. So there are two sources of heat here. The first one, it comes from the surrounding, okay, and the second one, it comes from the energy that being supplied by the power supply, okay. So you want the energy that being supplied, the energy that being supplied by the power supply only. So that's why you need to have another one that are not connected to the power supply. So later you can minus, then you can only get the energy that being used, okay, to change the solid to liquid. Okay, like this one is actually come from the surrounding, right, and also from the power supply. Okay, and this one is only come from the surrounding, right? And we know we want to use this formula, right? PT is equals to MC theta. Okay, so we only need the energy that being supplied by the power supply only. So that's why we need to have another one, okay, from the that are not connected to the power supply. So we know actually what is the energy, okay, what is the energy that being supplied by the power supply only. Later you just minus, okay. So this one is actually to determine, okay, the amount of heat of ice melted at room temperature. Okay, so this is the answer. The answer should be C. Okay, so another one, number 24. So this is water to steam. So this is liquid to gas. So liquid to gas is the latent heat of vaporization. And notice there is no change in temperature. So no change in temperature means latent heat. If there is a change of temperature, that one is a specific heat capacity. Okay, and then for this one, which one is not true? So P is the melting point of the solid. Wrong. Okay, the melting point is Q. Okay, so the answer is A. And for this one, it says 100 gram of ice is heated from its melting to 10 degrees Celsius. So calculate the total energy used. Okay, so we use the formula Q is equals to mc theta plus ml. Okay, why? Okay, so let's see the heating curve. Okay, right. So here it start from ice, right? This is ice. This is ice plus water. Okay, so you want to calculate, right? You want to calculate until all of it, okay, change completely to water. So means until here, right? Okay, this is the moment, okay, where all the solid or we all the ice will change to water. So you have to use, this is mc theta and this is ml. So that's why mc theta plus ml. So the mass here is 0.1. I changed to kg. Okay, and the C here for the water 4,200 and theta is 10, right? 10. Okay, and plus, okay, 0.1 and L is 3.36 times 10 power of 5. Okay, can you calculate for me? What is the answer? 37,800. Okay, so 3.78 times 10 power of 4. Yes, correct. So the answer is C. Okay, so we move on to the next one. Okay, so this one actually, I don't know why when I combine the PDF, okay, it become double. Okay, so I'm sorry for that. Okay, so let's see if it happen next time, we just ignore uh, the other question that being repeated. Okay, so just ignore that one. Okay, for number 2, this one diagram below shows the temperature time graph for heating of solid naphthalene. Okay, so it says here, complete the sentence by ticking right on the correct box. So BC is what? Okay, BC at this time the heat is absorbed. Okay, so this one most of you got it correct. And based on diagram above, state the melting point. So the melting point is 78. Okay, so 78 degrees Celsius. Alright, and then it says here, complete the following sentence by underline the correct phase in the bracket. So AB, you can see this one, the temperature increase, right? So if the temperature increase, okay, so means there is a specific heat capacity. Okay, specific heat capacity. Okay, and D. And this one, why the temperature remains constant at section B, C of the graph? Why it remain constant? This one we discussed so many times already. Okay, this is to overcome the force attraction between the particles. Yes. Okay. So this one is actually to break, okay, because heat energy is used to overcome the molecule bond. Okay, so that's the answer. And for this one, they ask you to explain in terms of energy, alright, why the reading of temperature remain constant. So for this one, the answer is just same like this one. It's just said used to overcome the molecule. The heat energy is to use to overcome the molecule bond, okay. And this one is say increase, okay. So increase here is actually to increase the kinetic energy. Okay, so increase after 20 minutes, so means at this part. Okay, if you see the graph at this part, why does the temperature increase? Okay, so what happened to the energy? So the energy is being used to increase the kinetic energy. Okay, and here you have to find the Q is equals to ml, okay, the energy absorbed, okay, during the first 20 minutes. So this one actually is changed, right, from solid to liquid. So m is, what is the mass? 0.2, okay, and L is 3.36 times 10 power of 5. Okay, so what's your get for this one, the answer? 67,200, right? Or 6.72 times 10 power of 4. Okay, correct. And this one is say which statements correctly describe the water in the glass after it's left for a few hours. Okay, so what happened at this time? Which one? It reached what? After you left the glass for a few hours, it will reach what? Yes, thermal equilibrium. So what does it mean by thermal equilibrium? Yes, no net heat transfer of energy, or it says the net heat transfer is 0. Okay, so this one. Okay, for number 9, state the melting point. So the melting point is when the solid change to liquid. So at this phase, okay, this one is not the melting. Some of you give me the answer 20. Okay, so this answer is actually 80. When the solid is starting to change to liquid, so that we call it as the melting point. So 80 degree Celsius. And calculate the specific latent heat of fusion. So we use Q is equals to ml. Okay, but can you notice here, it only gives you the power here, right? So what you should use, PT is equals to ml. So means we assume here that all the heat energy, okay, that being supplied, okay, is used, okay, to overcome the molecule bond between the solid, okay, so it can become liquid. Okay, so this one is QPT is equals to ml. So P is 100, okay, and the time, so it's taken from here to here, so 1000 minus 200, so you will get 800, and this one must be in second. Okay, and the mass here, so what is the mass? So the mass is 0.5. Okay, and you have to find the L here. So 100 times 800. Okay, and divide by 0.5, you will get like 1, 2, 3, 4, 5, 1.6, right? Times 10 power of 5. Okay, what's the unit? J, kg, negative 1. Okay, remember J, kg, negative 1 degree Celsius, negative 1. This one is for specific heat capacity, because I noticed some of you give me the wrong unit. Okay, so this is the answer. And state one assumption. Yes, this one mostly most of you got it wrong. Okay, so remember I told you, right, if they ask you what is the assumption that you made, so this one you have to see back your equation. So your equation is what? This is actually, you assume that the energy, the electrical energy, electrical energy is equals to the heat energy. Alright, so that's why you get this equation. You assume that electrical energy is same as the heat energy. So what is your assumption? Your assumption is you assume that there is no heat loss to the surrounding, or there is no energy loss to the surrounding. How much the electrical energy? That is the heat energy that being received. Okay, so this is actually there is no energy loss to the surrounding. Okay, there is no energy lost to the surrounding. Okay, this is the last question before I go to paper 1. Okay, so by using the molecular kinetic theory, explain why the temperature is constant between Q and R. Right? So this one means the energy used to break the bond between the molecule. Okay, so you put the answer here. Okay, temperature is constant because the heat used to overcome the molecule, okay, bond. Okay, and then another one mark you can say here, okay, this is called as specific latent heat of, okay, so Q and R is actually from solid to liquid, right? Okay, so specific latent heat of fusion. Okay, and you can put a bracket here, solid change to liquid. Okay, so that's you've got 2 marks. Okay, 1 mark for you said that the heat is used to overcome the molecule bond, and the second one you put what type of the specific latent heat, and you state the change of phase there, solid to liquid. So that's the 2 marks. Okay, so any question for the 4.3 exercise before I move on to the paper 1? Is it okay? Is it clear? All right. So let's move on to question number 1. Okay. So which SI unit is correct for the quantity given? Okay. So this is chapter 1. Okay. We already learned 7, right? So can I ask Jian Hong? Okay, Jian Hong. Can you give me, okay, one of the base quantity, okay, and the SI unit. Jian Hong. Any, yes, mass and kg. Okay, very good. Okay, and another one, can I ask Caroline? Okay, so Caroline, can you give me another base quantity and also the SI unit? You already learned 7, right? Other than state here. Other than already given in the question A, B, C, and D. Any other that you know? This one is 4, means there's another 3. Okay, Caroline, are you here? Okay, so what's your answer? Area. Area is the, okay, area is the base quantity, is it? What is the base quantity? Base quantity means you cannot derive it anymore. It's on the, it's already being simplified. You cannot derive it anymore. If area means you have to know the length plus the width, right? So this one is derived already because you use the multiplication to derive a new unit. Okay, so the answer should be, okay, length. This one already given. Okay, so never mind. Okay, so let's refresh. Okay, the first one is the length. Length is in meter. That's our unit. Okay, and the second one is the temperature. So the temperature is in Kelvin. Okay, and another one is the mass. Mass is in kg. Okay, another one is the time. Time is in second. Okay, and another one, what else? What else? Yeah, intensity. The light intensity is in a candela. Okay, and you already know amount of substance is in the mole. Okay, another one, yeah, electric current. Okay, electric current is an ampere. That's the only 7 base quantity. So other than 7 that I mentioned just now, okay, other than that, all that is a derived quantity. Okay, so what does it mean by derived quantity? So the derived quantity is actually you use a multiplication or division, or you use both, okay, to derive a new unit. So just now, like I show you the area just now, I use the multiplication, right? So if I use the multiplication to derive a unit, so that is a derived unit. That is not the base quantity. Okay, so the base quantity is only 7 that I mentioned. Okay, so this one is the length is in meter. Okay, mass is in kg, time is second, right, and the temperature is Kelvin. So this one, the answer should be D. Alright, for number 2, okay, so some of you got this one wrong. Okay, so remember how to form the equation, the straight line equation, right? Y is mx plus c. Okay, y is mx plus c. So what is y here? Okay, you have to see the axis here. So the axis of y, what is the title here? T square. So t square, okay, and x is actually the title for x axis. That is L. Okay, and the M is what? M is the gradient. Okay, so let's see if I took, remember I asked you, I teach you last week how to find the gradient, right? The first one, what you should do, okay, you take 2 points here, okay, and then you make a triangle. All right, so for this one, and you put the coordinate here. This one is 0, 0, and this one is 0 0.5, 2.0. Okay, and then I use it in the formula, the gradient, y2 minus y1 divided by x2 minus x1. So this is x1, y1, x2, y2. Okay, so 2 minus 0 is equals to 0.5 minus 0. So if I could calculate this one, I will got 4, right? So my gradient is 4. So I put here my m is 4. And the C, okay, C is actually the y-intercept. So the y-intercept is actually, it intercept at 0, right? So you don't need to put. So the answer, this one is t square is equals to 4L. So the answer is A. T square is equals to 4L. So that's how you make equation from the graph. Okay. Find the title of x, y axis and x axis. Then you find the gradient. Okay. And then for C, if there is intercept, so you have to put the coordinate here. Okay, for number 3, it says a shunt cycles at the velocity of 3.2 kilometer per hour. What is the velocity? So, kilometer per hour, you want to change to meter per second. Okay, so 3.2. Kilo is times 10 power of 3, right? Okay, so times 10 power of 3. Okay, and then 1 hour is how many seconds? 1 hour is 3,600. Okay, so you will get the answer. What's the answer for this one? You still remember? 0.888, right? So you will get 0.89. Okay, so the answer is B. Okay, for number 4. Alright, so it says here, which pair shows the correct derived quantity and its base quantity? Okay, what is the formula for momentum? Do you remember how to find the formula for momentum? What is the formula for momentum? mv. mv minus mu. mv minus mu is impulse. Okay, so momentum is P is equals to mv. Right? So this is the mass. So mass mean kg. This is velocity. That is ms negative 1. So let's check. Okay. It consists of what? What base quantity does it have? Okay. So this one is the mass. Yes, correct. Both have mass. Okay. And time, yes, they have time. But they're missing one more base quantity. There is length. Okay, so A, the answer is wrong. Okay, so the answer should be mass, length, and also time. Alright, for B, so what is the formula for force? This one is very easy. What's formula for force? Yeah, MA. Okay, so M is kg, A is acceleration, ms negative 2. Okay, don't be confused with velocity. Velocity ms negative 1. Acceleration ms negative 2. Okay, so let's check. Right, you see it consists of mass. Yes, we got mass here. Okay, we got length. Yes, we got length here. But how about time? Okay, so there is no time here, right? So B also wrong. Okay, the next one is the pressure. So do you know the formula for pressure? I think you already learned in Form 2, I think. Yeah. P is equals to F over A. Right? So force is the one that we already derived just now. Kg ms negative 2. Okay. And the area, okay, so we already discussed about the area also. M square, right? Length times width. So M times M, you got M square. So m square. Okay, so this one you can cut it off. Okay, so what it have here, it has mass. Yes, we got mass. We got length. Yes, we got length. And we got time. Yes, we got time here. So the answer should be C. Okay, can you understand for this one? Because I noticed some of you got number 4 wrong. Is it okay? Clear. Very good. Alright, for number 5. Okay, so this one, when it pass through the origin, we call it as a directly proportional. So the answer should be, oh, no? Okay. This one is one, if let's say 1 over t directly proportional. But this one, it says, if let's say we change it to t, right? So it should be inversely proportional. So the answer is B. If 1 over t, yes, directly proportional. But we change the x-axis to f against t. So f against t is a inversely proportional. Just like when we learn about wave right now, the frequency, right? If you remember, you were doing the exercise, f is equals to 1 over t. Then I ask you to plot a graph, right? So the first one is f, the x-axis 1 over t, it should be directly proportional. If the x-axis is only t, it will become inversely proportional. Okay, so the answer is B. Okay, for number 6. Okay, inference. So it said which inference is correct. So can you give me the meaning of the impulsive force first? What does it mean by impulsive force? What does it mean by impulsive force? Rate of change of momentum. Yeah. Okay. Rate of change of momentum. Can you give me the formula for impulsive force? Is it this one? Is it correct? Okay. mv minus mu divided by t. Right. Okay. So this one is actually for what? The one that I write this one. Yes, that's impulse. Okay, very good. Okay, this is impulse. Okay, the impulsive force should be F is equals to mv minus mu divided by time. Okay, so it says here which inference is correct. So you can see for the left, okay, on your left, okay, the egg, okay, is broken, but on your right, the leg is still the egg still not broken. So which one is the inference is correct? So impulsive force depend on the velocity of the egg. Okay, so you can see the height here is same. So if the height is same means the velocity also same because v is equals to s over t. So s is same means v also same. So A is wrong. So the answer should be B. The impulsive force depend on the time of the impact. If you increase the time of the impact, the impulsive force will be lower. Okay, so that's why you can see here the egg is not broken. Okay, so if the impulsive force is high, okay, the egg will broken. So it's only depend on the time of impact. If you want to make it the eggs, okay, you want to make it the egg not broken, you increase the time of impact. Okay, so the answer should be B. Okay, and then for number 8. For number 8, you have to see the direction of motion first. Okay, so the direction of motion is to the right. Okay, so here, the first point is come from here. It start from here. From here goes to here. If the direction of motion is to the left, okay, this one is only for ticker tape. Don't be confused with the car moving. If the car moving, yes, okay, if the car moving, you move from the left to the right, okay, you have to see from the left, okay, but for the ticker tape, okay, because we didn't do the experiment, so maybe you cannot imagine, okay, for the ticker tape, if the direction of the motion is to the right, okay, means the dots from the right come first, okay, so it start from here. All right, so let's check. You can see there is a change of distance there. Okay, so you can use this formula V is equals to S over T. Okay, so V is equals to S over T. So let's see, we start from here, right? The distance is decreasing. So when the S is decreased, okay, the velocity is also decreased. So velocity decrease means this one is the deceleration. So the object decelerates. Okay, and then after some time, does it, the distance become same? No, right? Okay, it's just keep decreasing. Okay, it just keep decreasing. Okay, there is no like constant distance. No, okay, it keep decreasing. So the answer should be the object decelerates. Okay, if you say that the object decelerate and then it move with the velocity, constant velocity, after some time, so let's say until here, now the velocity, now the distance decrease, right? Until here, let's say, starting from here, the distance will be same. If the distance is same, okay, from one dot to another dot, then we can say the velocity is constant. Okay, but now you can see the distance between two dots is decreasing. So velocity, the distance decrease, the velocity decrease. So the answer should be decelerates. Okay, so that's the way if you want to find the motion of the ticker tape. Right, for number 9, yeah, this one you are confused. Which one is V, which one is U? And another one, you forgot to put the negative sign. You forgot to put the negative sign because there are two different directions, right? One move to the right, one move to the left. So there is a change of direction. So you have to put either one is negative, okay? But for me, positive is to the right, negative is to the left, okay? So we take out the info first. What does it give here? It says the mass is 150 gram. Okay. And the time is 0.02. Okay. What is the U and what is the V? Okay. U is the initial velocity. Okay. So it says, okay, this is the U. U is 25. Okay. V is negative 18, or we can say, I said just now to the left is negative, right? So this one should be negative. Okay, and the right is positive. Okay, so V is 18. Okay, don't forget to put the negative and positive sign because there is change of direction. So after that, you can use the formula MV. Oh, got number 7. Really? Oh, sorry. I will go back to that question. Thank you, Yang. Okay, so 0.15 V is 18. Okay, 0.15 U is negative 25. T is 0.02. Can you calculate for teacher? Number 7. 3 to 2.5. So if you round off, you will get 3 to 3 Newton. Okay, 3 to 3 Newton. V as 18, negative 18. Yes, but if you put negative 18, so the U should be 25. Did you got the same answer if you put like that? No? Wait, let's change. Negative 18, 0.5, 25, 0.02, 15 times negative 18, negative 0.15, 25, got 0.02. You got negative, right? Yeah. Negative, okay. So the negative doesn't mean like that one is only the direction. Okay. So means it's the direction. So the negative means the force is going to the right. Okay. Right? Okay. The ball moves to the right. Okay. That one is only for the direction. Okay. But for the magnitude, we only take the positive one. Okay. Okay, for number 10. Okay, for this one, it says here, F is equal to MA, right? So 10 minus 4, okay? In order an object to move, okay, it has to overcome the frictional force first. So let's say if you push a box, okay? Let's say you give a box a force 200 Newton, okay? But, sorry. Okay, we go back to number 7. See, teacher very excited. Okay, so what is the front part and the back part of the car designed so that it can crumple easily? So this one is of course to reduce the impulsive force and to increase the impact time, okay, or the time of collision. So the answer should be number 2 and number 3. Okay, that is not to reduce the momentum. Of course, when you hit the if you hit the car with something, okay, of course there will be a large momentum produced. Okay, especially with the mass of the car is already very high and you drive a car with high velocity, of course the momentum is very big. Okay, so the answer should be number 2 and number 3. Okay. I'm so sorry. Okay, number 10. Right. So I already finished, right? All of the question until number 9. Okay. So number 10. Right, it says here diagram 6 shows a toy car of mass 4 kg. So the car is pushed forward by a force 10 Newton. So I think I give you example just now, like you push a box, okay, so you give a box like 100 Newton. Okay, then there is a frictional force, okay. When the equation mentioned to you the words, okay, rough surface. So rough surface, you mean you have to consider the frictional force. If they say a smooth surface, so smooth surface means there is no friction, okay. So if the rough, this one they already give you the frictional force. So let's say I give you 100 Newton, you push a box 100 Newton and the frictional force is 20 Newton, let's say. So the force will be used, the 100 Newton will be used to overcome the frictional force first, 20 Newton. Then after that, okay, the balance of the force that will be used to accelerate the object. So same like this one, okay. If you push the object 20 Newton, okay, and then the frictional force is 10. So mean you have to minus first. So 10 minus 4. Then you will get the net force, right? So 10 minus 4 is 6. So F is equals to M8. So 6, all right, and then the mass of the car is 4 and the acceleration you need to find, you will get A is 1.5. So number 10 is D. Okay, number 7, number 11. Number 11, there is no answer actually. There should be 2,500, right? Okay. So this is the new car, Pak Abu's new car. The car with a mass of 800 kg is moving with an acceleration of 2. There is a frictional force of 900 Newton acting on the car. So what is the force generated by the engine of the car? So the force generated means it's just like the force they used to push the box. It's just same concept, okay? So if you want to find, okay, the force of the engine here should be F net plus frictional force. Okay, and MA is the 800. Okay, acceleration is 2. Okay, and frictional force is 900 Newton. So we get 2,500 Newton. So this is actually the general equation. So let's say if you want to find the F net, okay, the F net means the one that you need the force used to accelerate the object. So you just minus, right? Plus this change here will become minus. So the engine force minus with the friction, or you sometimes you put engine thrust, okay, minus with the friction, you will get the F net. So this is actually the general equation. Okay, so this one no answer, I put it here, 2,500. Okay, number 12. Okay, this is actually what happened here. What physics, in what subtopic in chapter 2? This one. Anyone, and you have an idea? This is chapter 2 actually. Yes, free fall. What does it mean by free fall? What does it mean by free fall? Pulled by gravity only. Okay, the correct one is the actually when the object falls under the gravitational force, or gravitational force only. That we call it as a free fall. Not air resistant. Okay. The meaning is wrong. Okay. So the free fall is actually when the object fall, okay, under the influence of gravitational force only. So that we call it as a free fall. Okay, so let's say the question asks you, what does it mean by free fall? So that's the answer. Alright, and since here the diagram 8 shows Bob drops a feather and a stone in the vacuum tube. So vacuum tube means no air resistance. No air resistance means the object will fall at the same time. Okay, so what's the answer here? C. Okay, number 2 and number 3. Okay, number 2 and number 3. Okay, remember acceleration same. Okay, A 9.81. Okay, and also it will reach at the same time. Okay, number 13. Okay, this one you have to use this one, the last question. Okay, this is we have to find the displacement. So remember, for the displacement, okay, you have to find the shortest distance in the certain direction. That's the meaning of the displacement. Shortest distance in certain direction. So if you want to find the shortest distance here, it said W to Z, right? So the shortest distance should be from here to here. Okay, and after that you form the triangle. Okay, and this is 6. Okay, for W until here. Okay, for W until here just minus, right? 10 minus 2, so you will get 8 here. Okay, 10 minus 2, you will get here 8. So theorem Pythagoras 6, 8, this one should be 10. Okay, so the answer is A. Alright, if they ask you the distance, yes, then you have to add 10 plus 6 plus 2. So the answer is 18. So make sure you know the difference, okay? The displacement and also the distance. Alright. So I think I will stop until here. Okay, then we continue maybe after the school holiday. Right, and after this, for every exercise that I made, okay, I will make a video to explain the answer. So what we do during this time, we will discuss, okay, the question, but you have to give me the response. This one is actually you already answer, right? Okay, so for the next class, okay, we discuss the question, the new question, and all the exercise I will record the video, I put in YouTube. You can check, okay, your answer. All right, is it okay? Any question you want to ask teacher? Okay, so thank you class for today. Alright, so take care. Okay, don't forget, for those who still didn't do my homework, please do. Okay, today is the due date, sorry. Okay, bye-bye. Take care everyone. Okay, stay safe.
Thank you, teacher.
Welcome, bye-bye.
Thank you, teacher.
Thank you, teacher.
Thank you, teacher.
Oh, sorry, the project does day today. Thank you, thank you.
Okay, teacher.
Okay, bye-bye. Mana dia boleh masuk?